So our problem statement is to find the subarray which is having equal number of zeros and 1. So if a subarray is having equal number of zeros and 1, that means if we will replace 0 with -1, that means the sum of the subarray becomes 0 if we will sum all the elements of this, because it was having equal number of zeros and 1. So what we can do is we can replace all the zeros with -1, and then we will find the subarray which is having some 0. That means that subarray is having equal number of zeros and 1 in it. So that means what we can do is we can replace all the zeros with -1. So first step is to replace all the zeros with -1, and then our problem statement becomes to find the subarray with some 0. Okay. So to calculate the subarray sum, what we will do, we will maintain a prefix sum. So to calculate the subarray sum from this to this is j, this is I. So from to calculate the prefix sum from j to I, what we do, we maintain a prefix sum, and then we do prefix of I minus prefix of j minus 1. J is this and j minus 1 will be this. So in this way we will get the prefix subarray sum from j to I, this thing. So what we'll do, we will have this -1 minus j minus 1, this is -1, so this becomes 0. So this means that subarray from j to I in the original array is having some 0. So what we see in this, that, so what does that mean? It means that if we are currently at I, and prefix of I is -1, and if there exists a prefix of j minus 1, so that means if there exists a j minus 1 which is the value of prefix of j minus 1 is equal to the prefix of I, that means from j to I there exists a subarray which is having some 0. That's what we saw in this now. So we are at I, and prefix of I was -1, and we found out that there exists a j minus 1 which is having same prefix value as -1. So that means there exists a subarray from j to I which is having some 0 in the original array. So that's why this got repeated in the prefix sum subarray, prefix sum array. So what we can do is, if we found the element once again, that means -1 was already present, that means there exists a subarray from j to I in the original array which is having some 0. So we arrived at one condition, that if the element got repeated in the prefix sum, that means there exists a subarray from j to I which is having subarray sum equal to 0. We can also do that if we are currently at this 1. So 1 was already present in the prefix sum, 1 was already present here. So that means prefix of 0 1 2 3 4 5 6 6 0 1 2, 6 minus prefix of 0 is 0, because these are both equal. So that means there exists a subarray from j to I in the original array which is having some 0. So from this to this the sum will be 0. So our first condition is, if we get repeated elements, if we get repeat element in the prefix sum, that means that means there exists a subarray from j to I which is having some 0. So one condition is that the elements are getting repeated, and other, you can see that if we encounter a 0 in the prefix sum, That means the sum from the starting till that index is having subarray sum equal to 0. So whenever we encounter 0, that means in the original array we have from the starting till the current index, the sum of the subarray is equal to 0. So second condition is 0 encountered. So what we will do to count the number of subarrays having equal number of zeros and ones, so we will create a hash map in which we will store. So we will create a hash map to store the elements and to store the indices where the elements are present, so to get the repeating elements. So what we will do, we will first go through I equal to 0. We are at I equal to 0, and then we store, because it was not so there were two conditions, repeating and 0. So I equal to 0, which is 1, is not satisfying any of this condition. So because 1 is not present earlier and 1 is not 0, so we will simply store 1 in our hash map where 1 is present at 0 index. So we will move to I equal to 0, I equal to 1, and then we encounter 0. That means there is a subarray having sum 0 till starting from the starting index till that index, there is a subarray having sum equal to 0. So so we increased our count to 1, which is from 0 to 1 index, and we also stored that that 0 is present at index 1. So similarly we will go to I equal to 2, and then we will check if it is satisfying any of these conditions. So -1 was not present earlier and -1 is not 0, so it is not satisfying any of the condition. So we will simply store -1 and its index in the map, and then we will proceed to I equal to 3. And so I equal to 3 is 0, so that means there exists a subarray from the starting till that index which is having subarray sum 0, and so this was satisfying this condition, and it is now satisfying the repeating condition as well. So 0 was present at 1 index, so there exists a subarray from 0 from 1 plus from this previous index till the current index. From this to this, there exists a subarray in the original array which is having sum 0. So for this 0, which is at I equal to 3, this was at I equal to 1, we encountered two subarrays, one from 0 to 3 and other from 2 to 3, which is having subarray sum 0. And then we will go to I equal to 4. So we will check for this. So -1 is satisfying the first condition, which is it is getting repeated. So -1 was present at I equal to 2. So that means there exists a subarray from 2 plus 1 till current index, which is 4, from here to here in the original array. From 3 to 4, there exists a subarray which is having sum equal to subarray sum equal to 0. So for I equal to 4, we encounter -1, and then it is contributing to our subarray sum which is having sum equal to 0. And then we will proceed to I equal to 5, and I equal to 5. So we check for this condition, it is 0, so that means there exists a subarray from the starting till our I equal to 5 which is having sum 0. So for I equal to 5, we encounter 0 again, and then that means from 0 to 5 there exists a subarray, and 0 so 0 was present at 1 and 4. So and 0 was present at 1 and 4 also. So that means it is satisfying our second condition also, which is it is getting repeated. So there will be a subarray from this 1 plus 1 till our current index, which is I, which will be having some subarray sum equal to 0 from 2 to 5, from 2 to 5, and 0 was also present at 4. So from 3, it was present at 3. From 3 plus 1 till our current index, which is from this to this, there exists a subarray. So I equal to 5 is contributing to 2, 5 plus 4 to 5, and then we will proceed to I equal to 6. I equal to 6, so which is 1, and I equal to 6, so it is satisfying our first condition because 1 was present at this index, 0 index. So that means there exists a subarray from 0 plus 1 till our current index, which will be having subarray sum equal to 0 from this to this. So if we are given to only count the subarrays, so we don't actually need to store all the indices in our map. We can simply store the count. So let us say I am at I equal to 5. So that means if we stored only the count, so previously encountered 0 was 2, so we can say that there will be 2 subarrays from there will be 2 subarrays contributing to our answer. So this one is for like from the starting till that current index, so that we have to encounter. But if you will store only the count, that will also work. So let us say I am at I equal to 6, so 1 was present at I equal to 0, so we stored only the count of 1 encountered previously, so that were 1. So only one was present at previously, so that will only contribute 1 to our answer. So in this way we can count all the subarrays which is having equal number of zeros and ones by only counting the subarrays with sum equal to 0. So our answer in this case is 1 is this, and there are 3 subarrays from this, and there is 1 subarray from here, and 2 from here, and 1 from here. So total 8 subarrays which will be having equal number of zeros. So we'll quickly go through this pseudocode of this. So in this we have calculated the prefix sum, and then we are maintaining a map, and then if we have vi already present in our map, so we will increase the count by the number of element already present, and then if the vi is equal to 0, then we also have to increase by count by 1, and then in the end we will increase our count of the vi in the map by 1. So in this way we can calculate our answer and then return count of the value. So hope you like the video. Hit the like button and please subscribe to my channel. Thank you.